Pointers. Here, in this module, we will try to understand pointers through an example of row of safety deposit boxes of various sizes at a local bank. Each safety deposit box will have a number associated with it, which makes it easy for the cashier to quickly look it up. These numbers are like the memory addresses of safety deposit boxes. A pointer in the world of safety deposit boxes would here be a register of the cashier that stores the number of all the safety deposit boxes. In the computer, pointers are just variables that store memory addresses, usually the addresses of other variables. With the help of pointers, we can go to the address of the variable and can perform operations like data retrieval, passing them as a function parameters, etc. Here, if a customer wants to access his contents of his safety deposit box, he can do this by taking the address of his safety deposit box from cashier's register, which acts as a pointer. Pointers are variables that contain the address of a variable rather than the actual data of variable. The difference about them is that instead of containing actual data, they contain the memory location from where information can be found. Declaring a pointer. Int asterisk ptr declares a pointer to an integer variable. Size of pointer. The size of pointer does not depend on the type of pointer created. Size of a pointer is fixed and it occupies 2 bytes as in Turbo C++ compiler. Here, the integer type pointer ptr and character type pointer pttr both occupy 2 bytes each in memory. Getting the address of a variable, int a is equal to 5. ptr is equal to &a. The pointer ptr point to the address of a. Consider program 1. Main function starts, then 2 integer type variables a and b are declared and initialized to value 10 and 20. The swap v function is used to swap the values of a and b. It passes a and b as arguments to swap v function, which goes in x and y respectively. Definition of swap v function contains declaration of integer type variable t. Then the variable t is used to swap values of x and y. The printf statement then shows the swapped values of x and y, but the value of a and b remains same and is not swapped. Output of the program. X is equal to 20. Y is equal to 10. A is equal to 10. B is equal to 20. Consider program 2. Main function starts, then 2 integer type variables a and b are declared and initialized to value 10 and 20. The swap R function is used to swap the values of A and B. It passes address of A and B as arguments to swap R function, which goes in pointer type variables x and y respectively. Definition of swap R function contains declaration of integer type variable t. Then the variable t is used to swap values of x and y. Value in pointer x goes in variable t. Value of pointer y goes in pointer x, and then value of t goes in pointer y. The changed value of a and b is displayed through the printf statement. Output of the program: a is equal to 20, b is equal to 10. This method is called as call by value. In this method, the actual arguments in the calling function is copied into the formal arguments of the called function. The changes made to the formal arguments in the called function have no effect in the values of actual arguments in the calling function. This method is called as call by reference. In this method, the address of the actual arguments in the calling function is copied into the formal arguments of the called function. Using these addresses, we would have an access to the actual arguments, and we can manipulate them. Thus, the use of pointer makes swapping easy. Benefits of pointers. Pointers are more efficient in handling arrays and data tables. Pointers can be used to return multiple values from a function via function arguments. Pointers permit references to functions and thereby facilitating passing of functions as arguments to other functions. The use of pointer arrays to character strings results in saving of data storage space in memory. Pointers allow C to support dynamic memory management. Pointers provide an efficient tool for manipulating dynamic data structures such as structures, linked lists, queues, and stacks. Pointers reduce length and complexity of programs. They increase the execution speed and thus reduce the program execution time.